Hi, welcome back to the Introstat lecturing series. And we are in the testing hypothesis unit. And this is our second video about lecture number 8. We are talking about a hypothesis testing on two population means. And in our first video, we talk about if the both population standard deviations were given, and then we need to use the z-test. So we talk about how do we do the z-test for the two populations means comparisons here. Okay, so now for this video, we are going to continue, and now we are progressing to when the populations here, the sigmas here is unknowns here. That means sigma 1, sigma 2. So that means sigma 1, sigma 2 is not given. Okay? So it's not given, then what do we do? So if you take a look here, right? So this is what we discussed in the video number 1 here is for the sigma 1, sigma 2 are given, then we use the z-test here, okay? So now we said, hey, how about sigma 1 and sigma 2 is not given. So if it's not given, then we are using the t-test. Okay, so for the t-test, just like we did for the one population mean, if you want to use the t-test, we have several things we need to, the assumption and the conditions here. And here we said, the first things here we need to know is the independence assumptions here. Okay, so what is the independence assumption? That means when you take the two samples, right? Because we have two populations. So when you take the two samples, the sample, the units, the elements inside each sample, they have to be independent of each other. You cannot take the sample, they are, they related to each other. So because of that, that's why we need to have the independent, because when they related to each other, you automatically decrease the variations among that. So you will not be able to see the true population because the sample you took, they are the kind of, they all have some type of relation to each other, really cannot represent the whole population here, right? So the next thing here is independence also need to follow the 10%, the conditions or 10% rule. So what means the 10% rule? That means the sample size has to be less than, right? The sample size has to be less than 10% of the population. Okay, that means that, you don't really want to, like if you have a small population and then if your sample size take the 50% of the population in there, so that's why, so you have so that's what you try to avoid, if you have a very small population and then you take a very large sample and then you're going to bias your test results here. Okay, so the next things here we say we have to be randomized. Okay, so this is the randomized conditions here. So the randomized condition is we try to prevent some systematic the issues here. So it's kind of very similar like the independence assumptions here. So when you try to do this experiment, right? So we need to collect the data in a random fashion. So we don't want to say, so for example, you don't really want to say, hey, I want to see, how did the people they participate in the school events. Then I want to take a randomization. I want to randomly pick the people. I don't want to pick the same parents, like they all gather in the certain the stands, right? So if the parents, they all gathered in the sports stands, maybe those are the parents, they are interested in the sports. So if you only take a sample from that group, it's not a random, right? So you're going to have a systematic error as well. Okay, so then the next things here is we need to have a normal population assumptions here. That's what is the t-test. So when you take a sample, so the underlying conditions has to be the sample, the population you take the sample from need to satisfy the normal population assumption. Of course, in the real life, we don't really have all really truly normal populations, right? So some people, we also say the nearly normal, right? Near normal conditions here. That means as long as they are kind of not like too far away from the normal distribution, right? So we know the normal distribution is kind of like this, is symmetric, and also it's like a single peak, unless you take the sum distribution is like something like that, right? So as long as it's close enough to the normal distribution, then the t-test will work very well, okay? Then the next thing here is we need to have the independences group assumption. Okay, so this one is a little bit different than what the independence we talk about. So if here we want to take the two samples, right? So when we talk about the independence, that means this sample and this sample, these two will be independent. The first independent assumption is inside the sample, you have many elements, right? Those elements has to be independence here. Okay, so that is what is the t distributions here, what type of the assumption we have, and we talk this in our previous lectures, lecture number 7, when we do the hypothesis testing for the one population mean here, right? So the t-test assumption also need to satisfy here. Okay, so now this one is getting a little bit kind of complicated. So even the t-test, we have two kind of the t-test statistics here. Okay, so the first one here is variance not a pool, and the second time is variance pool. Okay, so what the variance is not a pool. So what is the t-test statistics? So we're going to look like. So the t-test will just be very, very similar like the z-test. So this is x1 minus x2. Okay, and then in here, because sigma 1, sigma 2 are not given, so I will use S1. So this is S1 squared to the N1 and the plus S2 squared to the what? To the N2s here, right? So this is, we call this not a pool, okay? So it's not a pool, and then if I use the pooled variances here, so what is the pool variances here? All right, so the pool variances here, so the t-test will be, this one is here, this is x1 minus x2, see here, okay? So this one is x1 minus x2, and then you will have S And this is the pool. It's very similar, like we did the two population proportion test, right? And then times 1 over N1 plus 1 over N2. So here, okay? So what is the S pool? Okay, so the S pool, it will be, so this one is N1 minus 1 plus okay, so it's N1 minus 1 plus N2 minus 1. Then this one is N1 minus 1 times S1 square plus N2 minus 1 times S2 squared here. And so in the TI-84, you do have the choice here also. Okay, so you can choose to do the pool or it's not the pools, right? So you can just input the data, and then if you choose the pool, then they will give you a test statistics and the p-value. When you choose the not pool, it will give you test statistic and the p-values here. In fact, the differences of these two really is not that big, okay? And with the good amount of the sample size, it's not that big. And the big differences here is, we know the t distribution, right? If you want to look for the table, right? So if you want to find the critical value, right? If you want to find the table values, right? So the degrees of the freedoms here. So the degrees of the freedoms will be the N1 plus N2, right? Because you have two samples. So it will be N1 plus N2 and what is minus what? Minus 2 here. Okay, so it will be N1 plus N2 minus 2. And if your variance is not a pool, okay, so if your variance is not a pool, then the degrees of freedom here, you need to what? Need to be calculated by what? By calculator. You won't be, so the degrees of freedom will be non-integer numbers. Okay, so it will not be a whole number. So for the pooled variances here, so it will be so it will be N1 plus N2 minus 2. And in here, typical we do is we typical is focus on we always want to like the pooled variances here. That means because I assume these two populations, they probably have different means, but I assume the variation for these two populations are very similar here. Okay, so just be careful. So if you use the pool, you will get a nice degrees freedom, and then you can use the t-table and try to, get a, t-table, try to get your critical values, or you need to use the calculator to do that, right? So, okay, so for the TI-84, how do you do these ones here? So these ones here is similar. You do a stat. And after you do the stat, you do a test, right? Okay, so after test, you do what? You do a two sample t-test here, okay? So you do a two sample t-test. Then you can input your information, so input your data. And after you input your data, and then it will ask you, you want to pool or not to pool, and then you'll be able to choose it. Okay, so for this video, I'm going to stop here. And so the last video, I'm going to practice two examples, and I'm going to show you how do we use the calculator and the R. So in here, I did not write down the R code. I plan to write it down for our next video when we use the real example. And then you can see how do I use the R code to try to, get the how to write the code to try to get the p-values here. Okay, now let's go ahead and take a break here, and then when we come back, we will take a look at our examples here. Okay, so looking forward to talk to you later. Okay, bye-bye.